Hello everyone, my name is Kristina Tornbjerg. I'm a PhD fellow at the research group Techno-Anthropology and Participation at the Department of Planning at Aalborg University in Denmark. Today, I'm here to present to you a paper by me and my colleagues titled Investigating Human-Robot Cooperation in a Hospital Environment, Scrutinizing Visions and Actual Realization of Mobile Robots in Service Work. This paper reports findings from an ethnographic field study in a real-world work setting where we research how humans and robots were cooperating in a particular environment in a hospital in Denmark. The research is conducted by me, by Kanstrup, also from the Department of Planning at Aalborg University, Mikael Skov from the Department of Computer Science at Aalborg University, and Matthias Rehm from the Department of Architecture, Design and Media Technology at Aalborg University. Along with other great colleagues, we are collaborating in Human-Robot Interaction Lab at Aalborg University. Now, let me introduce you to some context regarding our project. Because as healthcare systems around the world are changing and demands growing, resources must be used as effectively as possible. And a promising way to do so is to make robots assist in repetitive, time-consuming and heavy tasks. One of the healthcare settings that have taken robots in are hospitals. Now, in general, the purpose of deploying robots in hospitals is to automate processes and procedures that were previously performed by humans, enabling humans to spend more time performing complex tasks that robots are yet incapable of carrying out. In our research, we have investigated the cooperation and interactions between mobile service robots and kitchen staff in a hospital. And our research examines how robots affect existing work practices and describes how, in this particular work environment, robots designed to help workers perform logistic tasks were actually rather changing the nature of work. The robots were not really making workloads any less, and were inconveniencing other types of workers while performing their tasks. There's a lack of work committed to understanding the effects of deploying robots in work settings, but in recent years, human-centered perspectives on technology in the everyday life have received increasingly attention. A number of researchers have attempted to better understand robots in hospitals, and this paper contributes to this focus by investigating the use of mobile service robots in a real-life work setting while paying specific attention to understanding human-robot cooperation on service tasks in a hospital basement. Our research aimed to explore implications of workers cooperating with mobile service robots in order to gain understanding of robots in practice in a rather under-investigated area. And further, our research can be situated within ethnographic work as we have collected data through an ethnographic field study in a real-world work setting in a hospital in Denmark. The data was collected through interviews with hospital staff and observations of robots performing tasks. The results. The key finding from the field study is that there was a mismatch between the robots' anticipated tasks and their actual performance. The robots were deployed to support kitchen staff in their daily work routines and relieve them of physical tasks. But during this field study, it became clear that several issues affected the daily cooperation between staff and robots. And it was evident that the vision of simple automation being able to handle work tasks and procedures was unrealistic in practice. The procedures aiming to facilitate cooperation between kitchen staff and robots were complicated because the accomplishment of tasks comprised a series of invisible processes and interactions between the robots and the dynamic real-life work environment. Our research found that the hospital kitchen staff actually acquired a new type of task after the robots were deployed, placing service carts in certain locations, making the carts available for the robots to pick up. The kitchen staff informants reported how the only task performed by robots was the task of transporting service carts from one spot to another for the staff members to pick up the carts and push them around other parts of the hospital. But the robots did not perform these tasks autonomously. When interviewed, the hospital kitchen management explained how it was a simple task for a robot to move a service cart from one destination to another, because a robot would simply drive up to the cart, attach itself to it, and move it from point A to point B, as shown in this figure. Now, this is an example of how the robots are visioned to cooperate with humans in this hospital. As you see here, the envisioned human-robot cooperation consists of 7 steps, and this is how the hospital kitchen management believes the task of transporting a service cart from one point to another unfolds. Through our study, it became clear that the robotic workflows were far more complicated, because this flow chart illustrates the actual procedure of transporting a service cart from one point to another in practice, which is a lot more complicated than envisioned. Our figure here visualizes an overview of the several procedures and interactions that were invisible in the former workflow shown in the previous figure. Because here you see the steps observed during a single tour following and observing a robot transporting a service cart from one point to another in the basement. This visualization illustrated a total of 28 different steps in sharp contrast to the verbally reported 7-step workflow. Now, the complexity of the procedures draw attention to why robotic task performance in a dynamic work environment must be considered as complex, comprehensive, and context-dependent, rather than a simple, isolated automation of tasks. Another finding was that 5 of the 16 kitchen staff informants were following the robots around when they were transporting carts. These informants were spending extra time taking care of the robots and aiding them in fulfilling tasks. When interviewed, these staff members explained that they did so in case something went wrong during the robot's mission, and all 5 informants pointed out that they did so as they did not trust the robots to perform their allocated tasks, often because they had experienced how the robots encountered technical difficulties or were sabotaged by other professions working in the basement. This finding raised important questions about the implications of deploying robots to optimize work processes. Because after the robots were deployed in the hospital, the kitchen staff acted as caretakers for the robots, despite the robots being deployed to optimize service task performance and relieve staff. Our findings illustrate why visions of robots working in the hospitals were difficult to achieve and why the realization of cooperation between the kitchen staff and the robots was complex and led to changes in work rather than minimizing work. On the basis of our research, we can conclude the following. First, that robots changed the staff work rather than minimizing their workloads, not least as the robots added new types of tasks rather than minimizing tasks or replacing workers. Secondly, the everyday cooperation between kitchen staff and robots involved several problems, not least because a considerable amount of procedures involved invisible steps of work and different interactions between robots and the dynamic work environment. This study has also identified how the cooperation between kitchen staff and robots was complex within the given setting. Altogether, these findings provide an understanding of the key factors which underpin the complexity of robotic aid and assistance, revealing how robots necessitate changes in work routines rather than replacing the human workforce. We empathize the need to think of robots as new technology rather than a familiar and tested technology which can be simply adjusted and applied, because implementing robots in a real-world work environment requires more nuance than plugging in the technology and pressing its power button. In the same vein, technology must be developed beyond one-size-fits-all solutions because work environments vary. The mobile robots deployed in this hospital were of a type that had been widely fostered and used in industry, moving items from destination A to destination B in highly structured environment where humans working within a certain range of the robots are instructed and educated in sharing workspace with such. This kind of use and training are not matters, of course, when robots are implemented into hospitals. The humans who share their work, the much more complex and unstructured work environment with mobile robots, experience several problems incorporating with this technology as in industry cases. If robots are to participate in real-world work environments and cooperate with humans, the socio-technical factors must be focal, not least because humans affect the environment to which robots must adapt. And this focus is complex though, since mobile robots, at least the ones we have researched, do not hold any degree of social or artificial intelligence and are therefore unable to adjust their behaviors, their work, and their routines to the humans around them. Based on our findings, we posit that scrutinizing robots in relation to their work surroundings and contributions would be beneficial. We suggest a holistic, ecological perspective on robots when designing them for and deploying them in work settings. And this ecological viewpoint would promote an understanding of optimal cooperation and interactions between different groups of hospital service staff and robots. And with that, I would like to thank you all for listening to me. Thank you.